Okay, so this is an example on polynomials. Those of you who missed the Friday Zoom meeting, you really must watch this. And those who were at the meeting, you would benefit from this, as this is a different example. Okay, so more consolidation for you. Okay, so we'll start with this polynomial, right? I'm assuming people know the terminology associated with polynomials, because on the Canvas page, it directs you to copy all the definitions. Okay, there are a few terms that you must be familiar with. Okay, so let's see how we can graph this. As with any graph, it's useful to use intercepts. Okay, so let's go to our intercepts. Okay, to find, say, the x-intercepts, normally you would make y 0. And factorization is a great tool when possible, when you can factorize. So this one, the obvious common factor is x squared. So we factorize like this. Then we factorize further to find the zeros of the function, or the roots, or the x-intercepts, or the solutions to the quartic, etc. That's why it's important for you to be familiar with the terminology. Okay, so let's do this. Okay, so x squared, if this is equal to 0, right? If y is equal to 0, then that means x squared, x minus 1, x plus 1, x minus 2, sorry, x plus 1 is 0. So then that means either any one of these three factors could be 0. So x squared is 0, or x minus 2 is 0, or x plus 1 is 0, which gives us these solutions. Notice that x squared is 0. That's a double root, yes? Because that's essentially x times x is 0, which means x equal to 0 twice. Alrighty. And the significance of this is, if you remember from our work on parabolas, if you have a double root, okay, so that means the curve is going to bounce, okay, at that double root. So I'll move this so you can see, okay. So it's either going to be touching the x-axis and curving back up, or curving back down. Okay, that's what we expect. Because if it doesn't do that, if it cuts through, well, then that's no longer, that means there you go, you get two, yeah, if it cuts through there, well, it comes back up again, well, that's two roots. Okay, so that's the significance of a double root at a point. Okay, and that's going to help us when we're sketching to know that. So we know when we're sketching this quartic, when we're sketching around x equal to 0, because it's a double root, or two equal roots, we know the curve is going to bounce off the x-axis either this way or that way, depending on what's happening either side of that 0. Okay, so let's go to sketching that now. Okay. Okay, so this thing here, okay, so these are the x-intercepts. Okay, what we'll need to do now, mark them. Okay, you've got the graph there, but anyway, mark them. And then before you sketch, this is the final product, you need to check what's happening before x is minus 1. So you check the y value, the value of the function. Do you get positive, which means it's above, or negative? Yeah, so I'm going to cover this for a moment. Okay, so let's test x is minus 2. So the first value less than negative 1, keeping it simple. What do we get? Well, here we go. We get a positive, yeah, because we get minus 2 squared, so that's positive. And then minus 2 is negative, and minus 2 plus 1 is negative. So negative times positive is positive, which is why our graph before minus 1, okay, is above the x-axis, because we get positive y values. Okay, let's see what's happening between minus 1 and 0. Now we expect the graph to cut through there, okay, because minus 1 is a single root. So we expect the numbers to be, the answer to be negative. Okay, when we substitute minus a half, we expect to get a negative y value. So let's see what happens. Okay, so negative a half Okay, so negative a half squared, and then times negative minus a half minus 2, that's a negative number. And the minus a half plus 1 is positive, isn't it? Because that's like 1 minus a half, which is a positive. So we get a negative, yeah? So positive times positive is negative, which is what we expected. So at least we know we're on the right track. When you get to 0, remember, it's a double root, okay? Which means we expect the curve to touch the x-axis at that point, then go back down. So for values between 0 and 2, we're expecting a negative, yeah? So let's try x equals 1, keeping things simple. Okay, so when x is equal to 1, we get 1 squared, and then 1 minus 2 is a negative, 1 plus 1 is positive. Well, that's a negative answer, which is what we expected. Okay, so there you go. It bounces off at 0, goes back down, and now we expect it to go up because 2 is a single root. We expect the curve to cut through there. Okay, so let's test a value of 3. Again, trying to keep it simple. So y equals 3 squared times 3 minus 2 times 3 plus 1. So we get 9 times 1, okay, times 4. Well, that's a positive number, which is what we expected. And there you have it. Okay, so good luck with the questions in the textbook. I'm expecting some work on Monday. Okay.